Almost lunchtime.
Oh, I could check the batteries.
I better hurry this.
Geez, mate, I reckon you need to have a Bexy cup of tea and a good lie down.
Oh, yeah, I think you're right, mate.
Mind your head, son. You'll hurt yourself. Hang on, what are you people doing here? What's going on with the camera and the lights and that?
Well, we're making a documentary on battery safety.
Oh, terrific. You weren't much help with my little mate Sparks, were you?
We didn't know the battery was going to explode.
Yeah. How come the battery exploded?
Well, look, all you need... Can you hear me, mate? Yeah. All you need for a blast is some hydrogen gas and a source of ignition. In this case, Sparks' ballpoint pen fell on the terminals. There's probably some gas escaping through a crack or seal in the container. You see, the gas becomes volatile when the battery's been on charge.
Would you be prepared to tell us about battery safety?
Oh, no, mate.
We could really do with your assistance.
What, now?
Yeah.
Is that camera going? What's that?
Microphone.
Well, I've always, wanted to be on telly and that. Some of my mates reckon that I should be on the telly, and some of them reckon I shouldn't. Some of them reckon I got what it takes, and, well, hang on, listen, don't I need some makeup and that?
Yeah.
Hello, Janet.
Hi.
Okay, 5 checks, thanks. Mark it.
Battery safety, one take one.
Frame. And action.
Rightio then. For starters, hey, let's get the ground rules straight, mate. These signs around here aren't there to cover holes in the wall. All these signs in this room are for the benefit of the battery workers and also everyone else. That includes you, mate.
Sorry, mate.
Now, the reason all these batteries are here in the first place is to provide a power backup in the case of a mains failure. You see, in the typical Metropolitan Telecom Exchange, there are a number of strings comprising 24 cells. Now, each string produces the nominal 50 volts required to operate the exchange switching equipment. It's a bit of a mouthful, eh? Oh, listen, while I'm going along and that, do you reckon you could type up important points on the bottom of the screen, like you do in ads?
That's a good idea.
Do you want me to start again?
No, it's all right. We'll do that in the editing stage.
Editing?
Yeah.
Oh, editing. Like with an editor and that?
Yeah.
Oh, yeah. Right, now the next thing I want to talk about is how the battery's put together. Do you reckon you could computer up some pictures in that as I go along? Right, well, here we go. The outside casing, or the cell box, is made of a durable plastic. Now, inside are positive and negative assemblies, insulated from each other by microporous separators. The cell is also fitted with a safety vent and sealed with a gas-tight lid. Now, the cell is filled with dilute sulfuric acid, which forms electrochemical couples with the positive and negative electrodes, allowing electricity to be produced. When the two terminals are connected to an external circuit, electricity begins to flow. Yeah, good show. Now, there's something else I want to tell you about. It's this little bloke, the battery safety vent. Now, the vent has two primary functions. Firstly, it allows the volatile hydrogen gas to pass safely through this microporous membrane. Secondly, this acts as a flame barrier to prevent combustion of the hydrogen gas inside the cell by an external flame. Yeah. But don't worry, the point is that if the batteries are maintained properly, your safety is assured. And, hello, speaking of safety, here's young Sparks back. Hey, young Sparky, you right, mate?
Yeah, I feel much better, thanks, Max.
Oh, good. Well, look, you might wonder what's going on here. We're making a film on the Star. And look, it's great that you're back because now we can perhaps go run through a few maintenance procedures.
Tape change.
Yeah, tape. Oh, yeah, that's technical talk, Sparky. It means tape change. So, look, while they'll be tape changing, I wonder, Sparks, if you could dress up in some of the safety gear. What do you think? Oh, come on, don't be disagreeable, Sparky. It's your big chance. You're on television. Go on. Off you go. Go on. Go and get dressed up. That's the way. You'll be back in a minute, ladies and gentlemen. All dressed up and raring to go. Well, then we'll run through a few safety procedures with you, show you how to wear things, what to wear and so forth, and why it's good.
Shot 2, take 1.
And action.
Very flash, Sparky boy, very flash. Have a look at this, ladies and gentlemen, out there in television land. You'll see all the very important and essential safety gear. Sparky's wearing it. To start with, he's wearing the face shield. This will shield his face from liquid or acid that might otherwise spill and burn. Sorry, mate. Here we have acid-resistant overalls. You can spill anything on these overalls without having to worry about it. Gloves. Keep our little mitts safe and secure in these, and also in the case of Sparky, a neurotic nail biter. It'll keep him on the right track. Okay, down here we have steel toe-capped rubber boots. Just watch this. You feel that, Sparky? He didn't feel a thing, ladies and gentlemen. And Sparky, I know that you're eager to get started. I know you're anxious. I know you're excited about it. You're going to go over there and go through some maintenance procedures for us and for the ladies and gentlemen out there in television land, and I know you're going to love it. He's eager. Off you go, Sparky. He's eager, he's anxious, he's ready to start, he's raring to go, and I know you're going to love it. Sparks will now do a routine check of the batteries. For starters, a check of the electrolyte levels. Our man Sparks peers closely to examine the levels. Levels on the pilot cells seem okay, so this is a good sign. But, oh no, Sparks has found a cell with insufficient electrolyte. Sparks, being the diligent little technician he is, tops up the levels with distilled water only. None of that impure tap water for our batteries. Sorry about that little disturbance. Sparks has just informed me that he has found some corrosion in a cell, which has caused the case to crack. Sparks, the diligent little operator, come on, get on with it, is off to solve the problem. Get out of it. There he goes. And there's the little troublemaker. Corrosion. You see, here's the problem. So these cracks here have been caused by corrosion. Now, corrosion is simply a reaction to dissimilar substances, and it can be caused in several ways. It could be impurities in the electrolyte, manufacturing defects, or a lack of proper maintenance. Now, could you just take that, mate? Hello, in we come. Hello, testing. 1, 2. You with me? We right? Okay. In replacing a faulty cell, it's absolutely essential that you use an insulated tool, like this one. See? That's insulated. Because the careless use of a bare metal tool could cause an electrical short and in turn create an explosion. Oh, here he is, Sparks. Oh, terrific, he's got a new cell. Well, viewers, as you can see, here we have the correct lifting aid. Now, this little beauty has been designed... I have to speak up because of the racket noise. This little beauty has been specifically designed for lifting these large cells. These cells weigh more than 62.5 Ks, and the legislature of this fair country prevent anyone from legally lifting anything more than 18 Ks. Now, as demonstrated by Sparks here, the strap must be securely fastened. That's right, son. This prevents the battery falling off the lifting aid and onto poor Sparks' little toes. Thank goodness for steel cap boots, eh? Now, Sparky's going to now undo the strap and put that battery in position. Beautiful son. Oh! In we go. Good job. Don't knock over the strings, son. Okay. Well, you know, I reckon it's time for a tea break. Sparky, what do you reckon? Look, you film people, I think it's about time for a tea break. What do you think? Nice, Sparky. All right, take 5. We'll never get a cup of tea at this rate.
What's that one? Oh, no, there's the crack.
Yeah.
Better get that. Jeez, what?
Oh, you blokes are back, are you?
Yeah, spill your tea or something, did you?
Oh, listen, mate. It's better to shut up and be thought a fool than open your mouth and prove you are.
Sorry.
Oh, just watch yourself. Okay, now while you blokes were having your tea, young Sparks here, the diligent little technician he is, discovered an acid spill. Some acid had spilled from one of the batteries. Now what he's doing now is neutralising that acid spill with some soda ash. See, these spills are often caused by a crack in the battery. Now, speaking of cracks, when it comes to maintenance time, be sure to check for cracks. Well, we'll just fix this up, and meanwhile, you folks out there in television land, stay tuned. We'll be back very soon for another exciting moment in battery safety. Don't ham it up, Sparky. Just get on with it, will you? Come on. Right, well, here we go. The voltmeter. The voltmeter. Sparky, will you show the folks at home the voltmeter? He's hopeless. He's as useless as a pig up a tree. All right, now, to read the cell voltage, we need a voltmeter. And it should read between 2.17 and 2.23. And of course, it helps if you turn it on. 2.1718, 2.18, right on the money. Okay. Now, if the voltage is incorrect, it could be due to either corrosion or a bad connection. Right, well, I've been going on about a few things for a while now, and I think it's about time I tested your knowledge, you film people. What tool do we need to make a terminal connection adjustment?
That's the spannery head. That was like the hammer. No. This one, isn't it? Is it, Max? No, it's
that one.
Sorry, mate.
What tool do we need to make a terminal connection adjustment?
Don't know, Max.
Don't know, Mac.
Really got no idea.
No.
An insulated spanner.
That's absolutely right, Sparky. And what you other blokes are doing, you better pay attention. Okay. Well, Sparky, what are you going to do now?
I'm going to check the densities, Max.
He's going to check the densities. Off you go, then. Here, Sparks is using an hydrometer. This will provide us with an accurate reading. Under optimum conditions, the density reading should be 1245 plus or minus 5 points. If the density reading is incorrect, this could be due to the battery not charging properly. Now, it may be necessary, if this happens, to report it to your supervisor and fill out a DMR report. When using the hydrometer, care must be taken when removing the spout. In certain regions of this vast and dangerous continent, there have been reports of the sulfuric acid splashing onto the faces of the unwitting subjects. If this happens, it is advisable to rush immediately to the nearest eye wash station and liberally dose the affected areas with water. Listen, Sparky, do you reckon you could go over to the eye wash station and demonstrate for the folks at home?
No, Max.
What do you mean? In a minute?
No, Max. I'm busy.
How long will you be?
Well, too long, Max.
Thanks a lot, Sparky.
That's okay, Max.
Now, the first thing you do is you douse the whole area liberally with water. And I literally mean liberally. That's what that first one's for. The second one is for more or less the same purpose. You see, the idea is to... I hate this, Spark. The idea is to dilute the area and all the acid as quickly as possible and as much as possible. This one you do much the same with, except you do it more slowly. Try and keep your eye open. You see what I mean? It's easy. Okay. Now, after you've nearly drowned yourself, you might consider a couple of weeks in Fiji. Well, not Fiji, I mean, you want to go there. The Gold Coast. Now, thanks very much. Now, seriously, folks out there in television land, if any acid does splash on any of your delicate parts, like your eye, you should seek medical attention immediately. Speaking of the Gold Coast, Sparky, how are the temperatures coming along?
Fine, thanks, Mac.
Good. Having fun, are we? Doing the temperatures?
Yeah, Mac.
Good. If the temperature reading is other than 25 degrees Celsius, you'll need to make a density correction. How does one do this? Well, look and listen. By adding or subtracting 0.7 for every 1 degree Celsius above or below 25 degrees. Now, the exact procedure is detailed in the battery logbook. Seek and ye shall find. You'll happily discover, once the temperature correction has been made, that the density reading should be within the limits 1240 to 1250. I reckon it's about lunchtime. What do you reckon, Sparks?
I'll be with you in a minute, Max.
Right, well, it's on you. You're shouting. You might even have a liquid lunch.
Yeah, right, Max.
Come on.
All right, come on, Max. Later, thank you.
Thank you, mate. I'll take care of that. Producer told me over lunch he wants to move things through, so shot 3, take 1. There you go, son. Battery records. Now, after you've performed a routine check, it's very important you do your homework. By that, I mean the station record book has to be filled out. On closer inspection, we catch a glimpse of the history of the cells. The front page details the full range of checks that need to be completed. Look, here's part of cell densities, weekly check all the way through to a periodic test discharge. Our friend, the battery manufacturer, will only allow his guarantee if the battery's been maintained according to his instructions. Hang on. Bring us in a chair, would you, miss? Jenna? Thanks. Take it, will you? Thanks. Ladies and gentlemen, in summary, I'd like to remind you there's quite a few of you out there taking care of our batteries, and I mean right out there. When the sun dips its lead on those outback red deserts, the solar-powered repeater stations rely completely on our batteries for power. Then there's UPS, the uninterruptible power supplies that depend entirely on batteries for continuity of power during mains failure. Big-time stuff, not forgetting the emergency power plant that can't start without the battery that starts the engine. As you can see, the mighty batteries keeping the lucky country on the rails. Imagine a life without batteries. I mean, there wouldn't be the opportunity to order your favourite pizza from Dialadino's. How would you place a quick bet when that hot tip comes through? I mean, the implications are enormous. What the hell's going on with the lights? What's happening? Is that camera still working?
I think we're out of batteries, mate.
Oh, terrific.
Did you charge those batteries better?
No, mate, not me. That was Rick.
Oh, it's obvious you film people haven't been listening. Sparky! Sparks will help us out. Well, thanks, Sparks. One thing you can always count on around here, and that's Sparky and our trusty batteries. So remember, fellas, do your duty. We're all depending on you.